Why is an oscilloscope trigger essential for accurate measurements? Imagine trying to watch a movie where the scenes jump around randomly. It would be hard to follow the story, right? That's what happens when an oscilloscope has no trigger. It shows signals at random points, making the waveform look unstable and confusing. Now, think of the trigger as a director telling the oscilloscope when to start showing the action. It makes sure each display begins at the same point in the signal cycle. This synchronization is key to getting a clear picture of what's happening in your circuit. When you're measuring electrical signals, especially repetitive ones, you want the waveform to stay steady on the screen. If it jumps around, it's tough to analyze the voltage levels or timing. The trigger detects a specific condition in the input signal, like a certain voltage level or a rising edge, and then starts the sweep. You can adjust the trigger level to set the voltage point where the oscilloscope begins, and the slope to choose whether it triggers on the rising or falling edge. This lets you focus on the exact part of the waveform you need to see. For example, if you're troubleshooting a digital circuit and want to see a particular pulse, setting the trigger correctly will lock the display onto that pulse every time. Without proper triggering, the waveform would be all over the place, making it nearly impossible to spot glitches or measure how long a signal lasts. Modern oscilloscopes also have more advanced trigger options like pulse width triggers, which capture signals longer or shorter than a set time, or logic triggers for multiple signals. These features help you analyze complex systems more effectively. When measuring noisy signals, a good trigger can filter out background noise and focus on the actual signal of interest. Mastering trigger settings is a basic skill for anyone working with oscilloscopes because it directly impacts measurement accuracy. In short, the trigger is what makes the waveform stable and repeatable. It ensures each display starts at the same point, so your measurements are reliable. Without it, your analysis would be guesswork. Proper triggering helps you see the true behavior of your circuit, troubleshoot issues faster, and make precise measurements that matter in electrical engineering.